topic you want me to cover, you can just tell me. So based on that, I'll prepare that for that session next week. It will be in structural design only. So if you have any special topic or any particular topic you want me to cover, you can just inform me. I'll prepare the session accordingly. I hope you will, unmute and tell me. At least 2-3 people tell me, then I can prepare accordingly. Otherwise, I will take a session of my liking to you.
I suppose students should unmute yourself and express your view on the same.
Please unmute and give your opinion. Hello, anybody?
Ma'am, I think they're just a bit confused because we had a gap between the structure session and our current session. We'll give some time to them. I will circulate a form and try to collect their reply, and then we can finalize the topic.
Okay, just share me their feedback, Rintu, then I'll do it accordingly. Okay.
Sure, ma'am.
So
Sure.
please give it today itself so that I can do the preparation. Okay. Thank you, Rintu. Thank you so much. Thank you all.
Thank you, ma'am. Thank you all. So we just think about the same and let convey your response through the form. Thank you, ma'am.
Thank you. Thank you.
So today we will be discussing about Slab BBS. And in our last session, it was mostly focused on how to do the corrections in a beam detailing. Once the detailing is done after structure design, and once that is covered, you will have the detailing with you, and you will have to do a few corrections in order to get it scanned and prepare the BBS. Okay. In some institutes, we prepare the BBS manually, but in ours, we prefer the software method because it's fast and error free. Okay. And it is easy to check the results also. There are more advantages which was discussed in last session. So we'll continue with the next topic today. That is a slab BBS. And I request Ms. Nirmala to take over the session. PCC. Good evening, all. Yes, your screen is visible. You can continue.
PCC. So, good evening, everyone. Today, we will be dealing with Slab BBS. In the previous classes, we have already come across what is BBS and its uses, and also gone through the process and application of beam BBS. Basically, the process of slab BBS is more or less similar to that of a beam BBS with few differences. And now we look onto it one by one. And firstly, let me show an example of slab BBS which has already been completed for a villa project. And as you can see in my screen, these are the set of drawings that will be provided by the structural team in order to do the slab BBS. Basically, for doing the slab BBS, we'll be provided with two drawings, one for top bar details and the next for bottom bar details. And the procedure for preparing both of these drawings have been already discussed with you in the previous classes of structural training. And if anyone of you have any doubts regarding the same, can go to the recordings of that classes dealing with slab detailing. And the first step for slab BBS is to take a copy of each of these drawings provided by the structural team. That is shown in this second rectangle, and I have given names such as a top bar drafted copy, and the name for the bottom bars have been given as a drafted copy for bottom bars. And firstly, when we move to the top bar details, as we can see, most of the rebars have been provided by the structural team itself. So what we have to do is just to make some checking and to have a layer correction. So moving on to the check. The first check is to make sure that the all rebars have been drawn using polyline. So this is the drafted copy which I have edited, and if I go on to the properties, we can see that it is polyline. But when we move to the drawing that is provided by the structural team and select a rebar or select a rebar and go to its property, we can see that it is drawn using the command line. So we know that both of these two part of rebars represent a single rebar, or it should act as a single component. And in order to convert these two lines into polyline, we can just select the rebars and press join and press enter. Then these lines have been converted into polyline. See, we can see that the line have been converted into polyline. Similarly, we have to convert each and every rebar. If it is not joined, we have to select each and every rebar separately and press the command join. And we should convert them into a polyline format. And that's the first step. That's the first check we should do in the topo details. And the next check is to ensure that the rebars are placed with proper cover. As we know that the member along which my cursor moves right now is actually a beam, and the cover provided for a beam is basically 30 mm. And we can see in this figure, that is the drafted copy which I have edited, I have changed each and every cover into 30 as per the requirement. But in the structural drawing which we will receive, the cover might not be actually 30. See, it is only 20. So we should check the rebars whether a proper cover is provided. If not, we should move and align them as per the proper cover requirement. That is the second check. And coming on to the third check, we have to represent each and every rebar. That is, this red color things are rebars, and these lines represents the dimension line. And the third check is to ensure each and every rebars are denoted by a dimension line. So this circular thing is actually a node. So what basically a node does is that it actually connects the dimension layer with that of a rebar. By this dimension layer, we can actually understand that this particular rebar, that is the rebar with which the node connects this dimension line, is of 8 mm diameter, 8 mm diameter, and should be placed along this direction, that is from this point to this point, and should be placed at 200 mm center to center spacing. So that is basically the meaning of this particular dimension layer. So in the structural drawing provided, we can see that there are two such rebar, and in my drawing I have deleted one. So it's basically because since both of these rebars are one and the same, I can actually delete one, and it's only necessary to show a single rebar since both of these are same. And it's also okay if we place the both rebars also. But in some other cases, such as these type of rebars, that is, both of these rebars are not one and the same. That is, one is shorter and the other one is longer. And in these cases, we'll have to denote both of them using a single dimension layer and using two nodes. That is, we can see that these two rebars are connected with this a single dimension line with two individual nodes, like this. So the basic reason behind for me to using a single dimension line for both of these rebars is that what from this picture, what we actually mean is that these rebars are placed in when used in site, these rebars are placed one after the other, and the distance between a short rebar and a long rebar will be 200 mm center to center. And if we represent these rebars individually using two different dimension line, the distance will not be the same or not be the correct one. So in this cases, these two rebars should be named using a single dimension line with two different nodes. Other such example can
Actually, they are they have to be provided in alternate, like one long bar, short bar, then one long bar, short bar. In that alternate manner, it will be provided. So if you are not using the same dimension line, you will have to double the spacing between them in order to get it properly scanned. Okay, so that is what Ms. Nirmala meant. You can continue.
Other such example is observed in this case too. Here, one long and short bar is represented using a single dimension line. And the next check is to ensure that each rebar is represented by a single dimension line. That is, like we see in this figure. This is the figure that is provided by the structural team. We can see this single dimension. In the single dimension line, we can see that more than one set of rebars, that is these set as well as this set, is also represented by a single dimension line. But this is not correct one, because as we can see, this is a different slab from that of the remaining. When we move to the detailing, we can see that the slabs that are denoted by this kind of hatch is actually sunken slabs. And as we already discussed in the structural training, a sunken slab has some peculiarities, like each level is different from that of the other slabs. So all of these edges has to be noted as discontinuous edges. So in discontinuous edges, we should provide rebars like this, that is not continuing from one slab to the other. But once the sunken slab is finished, we can provide rebars in a continuous manner. That is, we can continue the rebars from one slab to the other. So from this, we can actually split the dimension line as per the requirement, like shown in this. That is, the near to the sunken slab, we will have to provide discontinuous rebar, and it is mentioned from this point to the point where the sunken slab ends. And once the sunken slab ends, we should provide another dimension line where we can provide continuous rebars from one slab to another. So it is represented by another set of dimension line. So likewise, we should provide different set of dimension line wherever required. And the next check is to ensure proper layer for the rebars as well as the dimension line. So as we are dealing with top bars, the rebars should be assigned under the layer SRC slab top bar. And this is the layer that has to be assigned to each and every rebars in the top bar detail. And correspondingly, the dimension layer should be assigned under the layer SRC slab top bar dim. These two layers should be strictly followed in order for our software, that is aadspro, to recognize these slabs and dimension layer. So till that, the top bar detailing is completed. Next, we can make a copy of the bottom bar details like this, and I have already given a name as drafted copy for bottom bars. And when we look into the drafted bottom bar details provided by the structural team, we can see that no rebars are mentioned in the given drawing. But we are provided with a note that we should provide 8 at 200 both ways. So when we do for slab BBS, we should mark the rebars as well as the dimension layer. So taking into consideration the note given by the structural team, we should actually draw the rebars and dimension layer as well. So since it is given that 8 at 200, we'll have to draw a rebar. And while drawing the rebar, we should always on the ortho mode, and we should draw the rebars. And wherever the slab is discontinuous, we should provide a L-shaped bend. And the bend is usually provided with a dimension of usually provided with 100 mm. And the distance between these bars with that of the distance between these bars and the slab beam edges, usually the cover itself, that is already discussed as 30. So we have to draw each bars and provide cover for each. Likewise, if we but in this case, the adjacent slab is a sunken slab, so we cannot continue a rebar from this slab to this. So we have to provide a single set of rebar for each sunken slab as well. But in the cases where the sunken slab is completed and this is another slab, we can actually continue the rebar from this slab to the adjacent slab like shown in this figure. Since there is no slab in this area that is mentioned as a cross mark, we don't have to extend these rebars to this slab. And as we know, the length of the rebar that is purchased from the market will have a length of about 12 meter. And if the span along which we draw the rebars is greater than 12 meter, we'll have to provide a lapping in that case. And in this case, we don't have any of the span greater than 12 meter, and hence we didn't give any lapping. But if we have a span greater than 12 meter, we'll have to provide lapping at the end where the rebar ends. And the equation for providing lapping is as per IS 456 2000 in the clause 26.2.1. And the equation for this LD is actually given as lapping length. And I hope this equation is already familiar to you. And once we draw the rebars, we can next denote them using a dimension layer. And the vertical bars are actually shown using a dimension layer that is placed in the horizontal direction, and the horizontal bars are actually noted using a vertical dimension bar. And the dimension, and in the dimension we actually mention 8 at 200, which is actually provided as per the requirement by the structural team in this figure. So in the dimension line we should mention 8 at 200. And for each and every rebar, we should connect that particular dimension line with a single node. And likewise, we should complete the entire figure. And wherever sunken slab, all the surrounding edges should be considered as a discontinuous sets, and the rebar should be bended up, and another set of rebar should be started from the point where the sunken slab starts. And the areas where there is no sunken slab, we can continue the rebars from one slab to the other, provided it is lesser than 12 meter. So after we complete both the top bars and bottom bars, one thing is that we should assign the layer as well. So in the case of bottom bars, the rebar should be assigned under the layer SRC slab board bar, and the dimension line should be under the layer SRC slab board bar dim. And this should be strictly followed for the aadspro to recognize. And once we complete both the top bars and bottom bars, we can actually take a copy of both of these top and bottom bars, and we can name it as scanned copy. So this is basically a copy that is used for scanning purpose. And so once we take a copy, we can move to the aadspro software. And in aadspro software, we should go to slab. Under slab, we have BBS scanning. In the properties, we should select the suitable dimension layer and reinforcement layer. And in our case, we'll be first dealing with the top bars. And in the top bar, we should assign the dimension layer as SRC slab top bar dim. That is this. And the reinforcement layer is SRC slab top bar. That is this. And once we assign both the dimension layer and reinforcement layer, we can close this window and move to the scan drawing option. Once we press scan drawing, we can see that the cursor has been changed to a square one, which actually implies that it is ready for scanning. Then we can actually scan, select this top bar drawing and click on enter. Once we press enter, we can see that the scanning is being done, and we should wait for few minutes. And once the scanning is being done, we can see that an additional number is forming in each and every dimension line like we see in this figure. And this actually denotes the number of the number of each bars. That is, I'll explain it. Once we complete this, we can move to the aadspro, and if we in the properties, we can see a table has been formed, and for exporting this table we have two options, one to Excel and the other to AutoCAD. To export this table into AutoCAD, we can go to the properties tab, and under that we can have export to. In the export to option, we can set it to AutoCAD, and once we set to AutoCAD, we can have a copy of this table into the AutoCAD. Currently, my export option is not working. So, Rindu Chichi, can you please show that export option?
Yeah, I'll share the screen. Okay. Now, is my screen visible? Just let me know when my screen is visible and you are ready.
Yes, Chichi, the screen is visible.
Okay, as Ms. Nirmala said, we'll have to enter the properties. And once properties are entered, you can go to the scan option. I'll just scan a slab with me. I'll just take a copy before scanning, because once it's scanned, the dimension along with the dimension will have the bar mark added. So it will be difficult for you to change it after that. If there is any correction and you have to do scanning and all, it's recommended you keep a copy and then go to the scan. Now here I'll just go again and initiate the scan option. Come back to AutoCAD. Select the drawing. Enter. Now we'll wait until the scan is complete. Once that is done, we can export using the properties. So we have the export option in three different sets as discussed earlier. We can export to AutoCAD, we can export to Simple Excel, and Excel with image. Okay. Now, once this is done, okay, it's complete. And we'll have a quick check. There is no red marks that indicate that all bars are less than 12-meter length. And as far as I see, all the bars are straight lines. Let me check. I have scanned the bottom bar and all these bars are straight lines. So now we can export the same. And for the same, just come and check your property site. If it's export to AutoCAD, only then you can export to AutoCAD. Otherwise, you'll have to change the option. Then just click export. Come back to the AutoCAD file. Click on a clear space so that there is sufficient space for printing the table. The print will be automatic. Don't disturb the system. Just wait. And if there is any mismatch in dimension, if they are too large to be viewed, then just go and change the dimension style to standard or any other dimension styles which can suit the proper appearance. Okay. Now you can see the table here. You can see the bar mark, bar type, the size of the bar, all are 8 mm bars. Then the number of bars of the same length. Then the total length to be cut. And here, since all the bars are straight bars, there is no other parameter like B, C, D parameters will be 0. So the length will be same as the A value. Okay. Now, if I am scanning the other one, it will be different because there are L-shaped bars and straight bars. It's a mixture of this two different types. And usually in slabs, we just have 3 types of bars used. That is the straight line bars, the L-shaped bars, and U-shaped bars as you see here. So all these 3 types are mainly used. Deviations are found rarely. Okay. Now that is about scanning and exporting, and we have an option for exporting to Excel too. So usually most of the companies prefer an Excel output, and here we use this Excel output for optimization of bar. And what is optimization and Optimax will be discussed later in the forthcoming sessions. I will just go to the export option. Automatically, the save as option will come up, and I can save the file. So I'll save as sample slab. Save, and opens automatically. So you have both BBS details and weight details over here. You can bring this back to AutoCAD by using the table option, and that method will be explained in the next session. For the time being, we'll have something interesting showcase in today's session. Before that, Ms. Urmila, is there anything left out from your portion to be explained?
I see there's a scanning for bottom bars as well.
Okay, the same procedure. Shall I continue with my part because it's already for 8:45.
Okay.
The same scanning procedure is the same when it comes to the bottom bar and top. Like actually, I did scan the bottom bar here, and if we are going to change to top bar, as mentioned earlier, you will have to go and change the properties over here. If it's bottom bar only, then we can use the same layer name. If it's top bar, use the layer name used for drafting the same. Okay, that is a change you will have to make, and then click scan option, go and scan the drawing. And if there is any error, it will be indicated in this table and even in the drawing, and you can correct the save and come back and scan again. Okay, so that is the remaining procedure for completing the slab BBS. Now, as I said in the first session of BBS, the 2D drafting in 2D BBS is the current era of bar bending schedule, and the future or the forthcoming options or a scenario of bar bending schedules will be the 3-dimension ones. So we'll have a 3D output of this to be produced so that we can easily visualize and plan which is the pattern for the rebar cage. And I'll be demonstrating how to bring the slab BBS from 2D AutoCAD drawing to 3D in Revit. Now we'll start with slab, and we'll also have a demo on exporting beam BBS. Okay. Now before that, I'll take a copy of the same. As I mentioned earlier, the scanned ones cannot be used for this purpose. That is the same reason why I took a copy and worked on it. And if I want to work on 2D to 3D, then I'll have to take a copy of the corrected drawing, not the initial one shared directly, the one which has been corrected. Okay. Now after taking a copy, draw a polyline around the slab in order to show the outline. I will just take a copy of the same and paste it for the other slab top bar too. Okay. Now after drafting the polyline, you can just go to Revit, just open a new file. And today I won't be discussing how to model rebar using the traditional method available in Revit. We'll be actually using a plugin which is developed by Xbuild soft in order to cut down the time taken for rebar modeling. Okay. So in this, for the plugin to work properly, you will have to use the structure template and open. And if you're interested for learning how to model rebar in Revit in the traditional method of manual drafting and all, manual modeling, then you can refer YouTube videos for the same, or you can, if you're too interested, we can host sessions for the same too. Okay. Now once we open, you will have you will have to set the units. I'll be using millimeters because all previous drawings are done in millimeters. Now the rest doesn't matter. So basically you will have to change the distance and length. Now after doing the same, you will have to go to the plugin option we have nearly 5 different options for slab, beam, and column. I think I demonstrated the same earlier, but I'll be repeating because this is more linked to the BBS side. Now we'll go to the slab draw option, which is used for producing the 3D rebar model. Now, based on which is the top bar and bottom bar, we have to generate it separately because the position of bars is different and the approach will be different too. I'll go with the bottom bars first. I'll have to select the either you can select the rebar name, layer name from here, or you can copy paste the same by editing the name from here. As it's known to me that I'm using SRC bottom bar and SRC bottom bar dime. So I'll be using the same here. I'll just select it from here. You can just select, type the name, and this similar ones will be coming up. So it will be bottom bar and SRC bottom bar type. Then click create option. Come to the AutoCAD file. Select the outline first. Then click enter. You'll have to click twice. Just wait. You'll see that Revit is blinking. Just come back. You'll see a warning. Don't worry about the warning. It's just because we are trying to use something using a plugin. Now the cursor is buffering again. That means we are ready to scan. And for this, come back to AutoCAD. Select the drawing and make sure that only one AutoCAD file is open at a time so that the software doesn't get confused between the files. Now just select, then click enter. You can see a pink line is running in between, showing that it's being scanned. So this you can see the speed of scanning. If you're into manual drafting of rebar or rebar modeling, it will take a lot of time. And this actually cuts down time by nearly 90% time is cut down by this method. Now, this close the same. If I want to continue scanning more, I can just continue with the same window, or just to check how much of it has been brought into the 3D interface, I'll just go to the 3D view option. And you can see here all the bars have been brought in. Now, this view is not so clear. You can just see it as lines. I'll just change a bit. Just change it to finer, and you can go with the shaded one. When you go shaded, the rebars will be covered inside the concrete. So it's better to look into wireframe, or you can change the appearance. For that, select the bar, right click, select all rebar in the host, and come to the visibility settings. Here, just select view unobscured and click OK. So if I'm changing to shaded or realistic, now you can see the bars have been shown as if the concrete is transparent. Okay. Now just go to the top view and show. Okay. Now this is the actual rebar mesh, how it will look in the site. Your construction site, after laying the rebars, it will look like this. Now I think it's better to go to the wireframe for clear view. You can see whatever you have drafted there, it has been reproduced here properly. And if you sit and draft the same, it will take ages and ages if you're not experienced enough. But I would recommend that you can try modeling on your own for learning better. Once you are good with it, I'll recommend using plugins like the one I'm using here. Okay, now we'll just move on to the rebar modeling of top bar. And when it comes to top bar, I have said earlier that we have the L-shaped bars and U-shaped bars used here. And the problem with these bars is that we can't directly bring them to Revit with the current situation of the plugin. We are researching on easier methods to bring it directly, but we'll have to, at this point of time, we'll have to just explore the same. And for that, I'll just select all similar bars over here and this one too. Okay. Now I'll just make sure all the polylines are selected and there are multiple lines over here. So I'll just unselect all the rest. For that, just do shift and drag select to unselect the other parts. I will just explore all these ones. Then just go and explore. Okay, I have already drafted the outline here. Just checking that. We'll come back to Revit. And here, go to the slab draw option. Select top bar. Select the reinforcement layer and the dimension layer. Select create. The same procedure. Go select your outline. Click enter. Just wait. You'll have the warning here. Just ignore the same. Wait for the scanning to start. Come back. Select the slab. Click enter. You can see that quick scanning is done. You can see there is a pink color line running through, indicating that the scanning is being done. Now, once it's done, Revit will show a blinking sign because there are some errors. Don't worry about the same. It's because we're trying to connect two different interfaces, that is 2D and 3D. Now, if I want to continue, I can continue with the same screen or just escape. I'll just go to the 3D view, zoom all, and here I have the top bar. All arranged, alternate bars are correctly arranged. We have the same shape bars arranged. The only thing is that this is not the one with bend lengths. So wherever there is a bend length, just select the bar. We'll just go and check here. AutoCAD file, we have bent bar here and bend length is nearly 100. So there you just come back to Revit, select the path, and here we have an option to add the hook. Hook is the same as the bend. Just go select the same. Starting and ending, if you are going to give the same hook, you can give that. Automatically the hook appears. If I don't want a hook at the end, I can just go apply none. You can see that only one set of bars have been given bend length. That is because alternate bars have been activated. So I'll have to go to the next set and apply the hook. Okay, so both the sets can be done. This can be done in less than 5 minutes. So it's not a big deal. Just make sure that you have explored the line so that all lines are getting exported to AutoCAD, to Revit. Okay. Now here you can see there is blank spaces, just indicates that there is an opening or there is no reinforcement in that region. And the rest detailing side and all can be explained later. So this is the basic way how you use a plugin to bring in the rebar. And you can even model this manually. The methods uses path method and path method here because that's more convenient. For customizing alternate bars, bends and start and end, and all these things can be easily customized when you're using the path method. Now, what a path method is and all, you can find videos regarding the same in YouTube. I can also share some samples for the same. Now, we'll just check how to bring the beams into 3D using the same BBS data you have done earlier. Now, I'll be opening the other file for the same. Okay, just open a reference file. I hope this is the same file I shared for your reference. If not, just understand that this will be the same procedure. Now I have some beams drafted here. We'll just go check for this long beam. How to bring the rebar to the 3D environment. And for the same, you will have to, if you are working with a new project, you can go for a new file. I'll just continue with the current file. Just select beam draw. You will have to enter the reinforcement layer. It's SRC reinfo. I have already checked the same. Now, if you're not giving the width and depth properly, what happens is that the reinforcement will be placed out of the host. And it is an error in Revit, which will end up giving no results, or sometimes the wrong profile will be generated. So make sure that you're entering the same dimension. So here, just check the dimension. If there is change in dimension, I recommend you do in steps, part by part, by changing the dimension in the window we have seen earlier. So here I have all the beams coming under 300, 600. So I'll be using the same size over here. It will be 300 and depth will be 600. The unit is mentioned here. Input units are mentioned here. So you can enter the same. And even the cover matters. If the cover is entered wrong, then the rebar might get misplaced from its actual position. So just check the cover provided in the drawing and come back. And as I mentioned earlier, it is the effective cover to be provided, not the clear cover. So this is nearly 50 mm. So come back to Revit, correct this value as 50, then go to create option. You can see it's buffering and ready to scan. Come to the drawing. All you have to do is select the rebar. No other selections involved. Just select the rebar and click enter. You can see that bar color is changing, indicating that those bars have already been reproduced to the Revit environment. Now, if I want to continue scanning, I can continue unless and until the cursor is in box shape. That indicates that it's continuing the scan. So if I click enter, now the crosshair has appeared instead of the box cursor. That shows that the portion I have selected, till the portion I have selected has already been generated. Either I can continue or terminate the procedure and start with a new portion. I'll just continue for the time being and do it for this entire beam. And for the same, I'll be selecting. And in case if you accidentally enter twice, click enter twice, then you can go and restart the scan. There is no restriction that once you did it once, there you can't repeat it twice. You can even do it twice. So once it's completed, scanning is completed, all the bars will change its color, indicating that they have been scanned into the Revit environment. Now, if I want to continue, you can ignore the warnings. You can either continue with the next beam. I'll just add one more beam. I'll add this smaller one. Okay, just click enter. And this time I'm just going with the observing the results. Just close, close. And I'll go to the 3D. Zoom in. And you can see something has been appeared here. That something is nothing other than the rebar I have generated. Now this is the top view. I'll go to the inclined view so that you can see. Okay. Now all you have to do is that you will be able to generate the 3D using Estimax platform. You'll get the structure profile, like the structure beam column layout can be brought into Revit using the earlier plugin, that is Estimax to Revit plugin. I think I have covered the demo for the same in the initial sessions. I'll just include the same in forthcoming sessions too. So once you have the beam column layout already modeled, you can just change the host of these bars and bring it to the correct position. So it's not a tough job to do it after generating the same. If you were to draft this manually, selecting the bar, changing the shape code, arranging the positions, all these will consume like almost twice the time for producing the same using the rebar plugin. So I'll recommend you can use plugins like Xbuild plugins, or you have plugins like Beam Studio. You will have to work with the same and see which suits you. Okay. I think Beam Studio doesn't give much access to its tools without purchasing. You can use Xbuild or okay. I'll just recommend that use a plugin to cut down the time. If you don't have access to plugins, you can go for the usual procedure of drafting. And to begin with, it will be better you learn to draft the bar or model the bar on your own, so that you will be familiar with how to handle situations. for different structures like a footing, a pile cap, a pile, a circular column. These are not the typical ones. These are different structures that can challenge you to do a different rebar modeling. All these can be only done manually. The regular ones like the common beams, columns, slab and all can be generated using plugins. That will be the easier method. So with this, the BBS brought into 3D is winded up. We'll have the session for column row when column BBS is being taught. And I'll just demonstrate the Estimax to Revit plugin when we are having the session for estimation. Okay, if you have any doubts regarding the same, you can ask me right now, or you can mention the same in the group or personally, how you feel comfortable. And make sure that you fill the form I'm sharing in group for collecting the topics you are suggesting for the next session. It will be an exclusive session delivered by Dr. Lathi ma'am. So I would recommend that you do give your suggestions so that you will get an output that is more customized. Okay. Shall we wind up the session? Is there anything more to discuss? Any doubts or queries to be covered? And if majority of you are interested for doing the slab rebar modeling in Revit platform, then we can arrange sessions for the same. You can also get a glimpse of how to add rebars, how to model them in 3D, because it's a future option. If a majority of you is interested, we can arrange the session. Otherwise, it will be like a personal session, which I don't encourage. Okay, thank you all. Thank you, Ms. Nirmala, for the wonderful session.
Thanks.